What is the Pythagorean theorem? It is a theorem that states that for every right triangle, the squared length of the hypotenuse or longest side is equal to the squared lengths of the legs or the two other sides combined. Simply, it is leg 1 squared plus leg 2 squared equals hypotenuse squared. Or, by substituting leg 1 and leg 2 for A and B and the hypotenuse for C, we get A squared plus B squared equals C squared. And here's a visual representation of the A squared plus B squared equals C squared formula. So how do we know that this theory is even real? How do we know that this formula works? So we have decided to make a graphical representation of this theory. Here we have a right angled triangle. First, we rotate the triangle so that the hypotenuse or the longest side is at the bottom. So we can see that it's a straight line. So we represent the squares of the and we mark them as a squared. By making two columns of this triangle, we can clearly see they will be able to fit through this empty rectangle space that we have. As such, they fit exactly through this rectangle space. So this is our first polygon. Now we will be doing with C. So here's our original triangle again. It has the same measurements as the. So we rotate this triangle so that the hypotenuse is again parallel to the ground. Now we make a graphical representation of C squared by making a square and labeling it as C squared. And again, we have two more similar triangles. They are congruent to the original one. Note that these ones are again the same measurement as the first. So they again clearly fit our, and as you can see, these polygons have the same measurements, and these polygons are exactly the same in shape and size. By removing the triangles, we get the original theory, which is a squared plus b squared equals c squared. So this proves the formula because these three triangles we have formed, we had three triangles on both sides. So when we remove the triangles, we are just removing um, the same thing on both sides, which basically means that since we have removed the three triangles on each side, we have now the squares left. And since we know that the polygons were exactly the same, so are the squares. So what's the point of learning Pythagorean theorem? We will never use it, right? Well, there are actually a lot of real world um, problems which can be solved by using the Pythagorean theorem. For instance, consider this real world problem. Matthew needs to get to the restroom as soon as possible. He is at the corner of the quadrangle closest to the grade school chapel, and the one directly beside the chapel was locked for maintenance. So he can either go to the bathroom at the end of the other end of the quadrangle or at the other end of the canteen. Now let's say that the area of the quadrangle, a square, is 900 meters squared, and the measurements of the canteen are 15 meters and 60 meters for the width and length respectively. At the opposite corner of both, there is an open bathroom. Now, assuming that Matthew took the shortest route to the restroom, which of the restrooms would he reach first if he ran at the same speed to get to either? So, first thing we do is to make a visual representation of the problem because just looking at the word problem could be kind of daunting. So, we make a visual representation based on the given facts. Here we have Matthew represented by the X and the restrooms represented by the stars. So to solve this problem, the first thing we do is to find the length of the quadrangle. Because the quadrangle is a square, we know that all the sides are equal, and because the area of the square is simply the square of a side, or basically because the area of the the square or the quadrangle is basically twice of its length. All we have to do is to find the square root of 900 meters, which is 30 meters. Now, how are we going to calculate the shortest path to the restroom? It's actually simple. Because whenever we calculate the shortest path to something, it's always a straight line to uh, uh, that location. If we needed to find the shortest route to the restroom, for instance, in this case, all we had to do is to draw a straight line to the restroom. So as such, we will have a straight line to both restrooms. In this, all we have to do now is to find the length of these lines that we have just drawn, the shortest route. We have to find the length of the shortest route of these two triangles. Now, notice that in both sides, they are just essentially triangles. And given the Pythagorean theorem works only with right angle triangles, and because rectangles and squares always have right angles in the corners, we have essentially just formed two triangles which we can use the Pythagorean theorem on. So knowing that a squared plus b squared equals c squared, we can just plug in the values of, for instance, these 15 meters, 60 meters. All we have to do is plug in the values to calculate the length of the hypotenuse, or the longest side, or the shortest route to the bathroom. So here we have 15 squared plus 60 squared and 30 squared plus 30 squared. Now all we have to do is to find the square root of the measurements, because we already have the answers here. 15 squared plus 60 squared equals 3,825, and 30 squared plus 30 squared equals 1,800. All we have to do now is to find the square root of these measurements. So I have put the square roots here already. 61.85 is the square root of 3,825, and 42.43 is the square root of 1,800. By just comparing these two values, we can clearly see that taking the quadrangle would take a shorter time than taking the canteen. So from this, we can clearly say that if you ran at the same speed, it would take a shorter time to get to the bathroom or the restroom using the quadrangle than it would to take the one of the canteen.